Okay, literal equations. They're a little bit different than regular equations because they have more than one variable. So the first thing we need to do is look for the variable that we're asked to solve for. So I see that I'm supposed to solve for x. So I look in the equation and I see x, but it's in the denominator. So the first thing I need to do is get the variable x out of the denominator. So if I'm dividing by x, I'm going to do the inverse of that and multiply by x on both sides of the equation. Okay, and at that point, my x is on the right, will cancel, and you'll see that it pops up over on the left side. So I have r times x equals c minus s. Okay, x is still not by itself, so I need to undo the multiplication by dividing by r on both sides. The r's will cancel, and I'm left with x all by itself equaling c minus s divided by r.
Okay, now we're going to continue on with example number 2, and as I'm sure you've figured out, this is no longer Ms. Vaughan speaking to you. This is Mr. Auble taking over for number 2. Now, in question number 2, we're going to solve for y in terms of, looks like there's a couple variables here, so we have another literal equation here. So we're solving for y, but there's a problem here. And if you'll notice, when you take a look, when you're solving for y, you might be asking yourself, which y are we supposed to be solving for? And how do we do that? You see there's a y here in the first term, it's xy, and there's a y there. There's also a y in the second term. So you may be thinking, you're going, well, what do I do now? There's two y's there. Well, this is an example of an equation that can only be solved if you use the distributive property. The distributive property must be used here. Whenever you see the variable that you're looking for in two different terms, you must use it. And we kind of say distributive property, but we mean distributive property in reverse as well. So what's going to happen here, since there's a y in both terms, we are going to take the y and put it out front, and we're going to multiply by the quantity of x plus 3, and we're going to set it equal to 6. So you notice if you think through, I'll pause a second, but you'll notice that if you multiply the y times the x, you'll be back at the xy, and y times 3, you'll be back at the 3y. So at this point in time, we only have one y, so we can go ahead and solve for this particular y. And if you notice here as well, we've got two factors. Y is a factor, and the quantity of x plus 3 is a factor. So if I'm going to get y all by itself, I have multiplication right now, so I'm going to have to undo multiplication. And I'm not going to divide by x, and I'm not going to divide by 3, because neither one of them is a factor. I'm going to divide by the entire quantity of x plus 3 on the left side, and by x plus 3 on the right side. So you notice what happens then if you come back to the left-hand side, the x doesn't cancel out with the x, and the 3 doesn't cancel out with the 3. What cancels out is the entire factor of x plus 3 cancels out with the entire factor of x plus 3. And what we're left with is y all by itself on the left-hand side, which is what we're trying to find. And on the right-hand side, we have 6 in the numerator and just x plus 3 in the denominator. And we have now just solved for y in terms of x.
All right. Okay, back to Ms. Vaughan. This is number 3. So we look to see that the variable we're searching for is x. And as I look through the equation, I see an x here. And I keep looking through. Uh-oh, I see another x here. But it's a little bit different than example 2. Because as you can see, the variables are on opposite sides of the equal sign. So we have to do a little bit different thing here. So we need to get our x terms to one side. So I'm just going to choose the left side. So I'm going to subtract the entire term on the right, and I'm going to subtract it on the left. So the terms will cancel on the right, and I'm left with ax minus bx plus 3 equals negative 4b on the right. Okay, so now it's looking like example 2. The x variable is still in two different places. We see it here and here, so we know we're going to have to use the distributive property, reverse distributing. But before that, we have this term right here. So we have to get rid of this on the left, comes over to the right when we subtract, and our constant will be gone over here. So we have ax minus bx equals negative 4b minus 3. Now we're ready to go for our distributive property. So factor out the x, it comes out front, and we're left with an a from the first term minus b from the second term. And the right side doesn't change, just rewrite. Okay, so x times the quantity a minus b. So this is multiplication. So we need to do our division by the entire quantity, a minus b. Divide the other side by a minus b. Our x variable is now by itself, which is what we needed to solve for from the beginning. And it equals negative 4b minus 3, all divided by a minus b.
Hello, it's me again. And now we're going to solve example number 4. And when I look at number 4, I'm thinking, uh-oh. Just like before, it looks to me like we have the variable k, because we are solving for k. I should have mentioned that at the very beginning. We are solving for k. But once again, we have k in two separate places. Now, unlike 3, where the k was on opposite sides, we do have the k's on the same side, but one of them is in the numerator and one of them is in the denominator. That poses a bit difficulty for us. So what we're going to do is, just like one of the previous examples, I think that was example number 1, we are going to multiply both sides of the equation by the quantity kp, so we can get that kp out of the denominator, because I don't like it there. So I'm going to put parentheses around both sides, and I'm going to multiply the left side by kp, and the right side is going to get multiplied by kp. Now on the left side, since we have factors of k and p, both in the numerator and the denominator, it's okay for me to cancel those two out. So I can cancel out kp with kp, and all that's left on the left-hand side of this particular equation now is 5k minus 3p. And I'm going to go to the right-hand side. Well, we have 12 there originally, and we multiply times kp, so that means right now we must have 12k times p left. So let's go back and let's see where our k's are now, because remember, we're solving for k, and we have them out of the denominator, which is a good thing. But once again, we have them one on the left side of the equation and one on the right side of the equation. And this is just like my example from earlier, where we have the one on the left, we have one on the right, so we have to get them on the same side. So I'm going to choose to put them over on the right-hand side. All the k terms are going to go to the right-hand side. So right now, on the left-hand side, I have a positive 5k. You may think that I have to add because there's a negative here, but that negative goes with a 3p. It has absolutely nothing to do with the 5k. The 5k is a positive 5k, so if I want to get rid of it, I'm going to subtract 5k on both sides. So minus 5k on the left, minus 5k on the right. And I chose to put it to the right of the 12kp minus 5k because I'm not going to be able to actually subtract those numbers because they're variables. So now if you look on the left-hand side, we have some cancellations taking place. 5k minus 5k is gone, and all that's left on the left-hand side of the equation is negative 3p. And on the right-hand side, I have 12kp minus 5k, which are unlike terms. All right, so now I'm at the point where I'm thinking, all right, I'm still trying to solve for k, and I'm feeling pretty good about it now because even though they're in two separate places, they are on the same side of the equation. So that's good. And we only have one step left to use, and that's going to be the distributive property. So on the left-hand side, I'm going to rewrite negative 3p just like it was before. But on the right-hand side, I'm going to use the distributive property and put the k out front times the quantity of 12p minus 5. So if you look right now, we are one step away from finishing this problem. And if I look at it, I can notice I still have k multiplied by 12p minus 5. That's a multiplication problem. So I'm going to do the inverse, which is division. So I'm going to divide the right side by the quantity of 12p minus 5. because I want to get rid of that 12p minus 5 on the right-hand side. And I'm also going to divide the left-hand side by 12p minus 5. So just reminders I said earlier that when I do my canceling, I'm not canceling out the 12p with the 12p and the 5 with the 5. I am canceling out the entire factor of 12p minus 5 with the entire factor of 12p minus 5, and all that's left on the right-hand side of the equation is k, which is what I'm looking for. And so my final answer, and I'm going to leave it in this form, is negative 3p for the numerator over 12p minus 5 for my denominator. And that is how you solve that particular problem for k.
Got. Okay, last example, number 5. So it says here that we need to solve this. It should look familiar to you, by the way. A equals pi r squared is the formula for area of a circle. So here we're solving for r, and I look in my equation or my formula here, and I see r there. But it's r squared, so we will deal with that in a little bit. First thing, though, is to get r squared by itself. So right now it's pi times r squared, so we do the inverse of multiplying, and we will divide by pi on both sides. So the pi's will cancel on the right, and we're left with a divided by pi equals r squared. But I really don't care about r squared. I want r. So to undo something that's squared, the inverse of that is to take the square root. So I'm going to take the square root of both sides, and I'm left with the square root of a divided by pi equals r. Now, we can write this as a separate numerator and denominator. We can break this apart. We've talked about this before. So you could have the square root of a divided by the square root of pi if you needed to. And that is the end of this video. I stopped it. We wanted to stop it, right?